Hi students, welcome in the chemistry classes. So we are seeing the coupling reactions. Actually we are seeing here the organic name reaction mechanism in which we are seeing the coupling reactions. Actually in all these reactions we are seeing that these reactions are catalyzed by organometallic catalyst. Okay, so these are well known as organometallic coupling reactions. We can call them organometallic coupling reactions because we are applying here the organometallic catalyst. Okay, so all of these reactions are almost same that you are seeing in my previous lectures. All reactions are almost similar to Suzuki coupling reaction. So you can write down all of these coupling reactions simultaneously on a same notebook. Okay, so that you can understand what is the basic difference between these coupling reactions. Okay, so same type of reactions are happening, same type of mechanism, but the reagents are different. Okay, so actually it is also a cross coupling reaction, means two different reagents we are taking and between them a carbon carbon bond is being formed. Okay, and here there is coupling between the organo zinc compound, means one compound is organo zinc compound. It means with the organic group a zinc is attached. Okay, and the other compound is a halide or a triplet, and this is happening in the presence of palladium or nickel catalyst. Means we are taking here palladium or nickel in zero oxidation state as a catalyst. So what is the reaction, what is happening actually? See here, this is our halide, this is treated with organo zinc compound. This is our organo zinc compound, and these are treated in the presence of either a nickel catalyst, these are ligands, L means ligands, or a palladium catalyst. This is palladium with ligands in a presence of suitable solvent. So what is happening? Actually this bond will break down from here, this bond will break down from here, and you are getting a new carbon carbon bond. It means you are getting a new compound by the coupling. Okay, now what is the criteria which can be the R groups? See here, R1 may be any aryl group, means in halide. It may be aryl halide, it may be alkenyl halide, or it may be acyl halide. Okay. Similarly, R2 may be either aryl group, it may be heteroaryl group, means besides carbon some other atoms can be present, or it may be alkenyl group, and it may be allyl group or homoallyl group. Now X. X you know is any halogen, Cl, Br, I, or a leaving group like OTF, or Y. Y is also a halide. So Y can be Cl, Br, I. Any of these. Okay, and Ln means these are the ligands. These ligands may be ppS3 ligands. This may be given to you DBA ligand or DPPE ligands. Actually, these all ligands are electron rich. Okay, these are electron rich, so they provides a better medium for the oxidative addition reaction. Okay, so these ligands are generally used. All right, now we comes to the mechanism. Actually, the mechanism is happening by a catalytic cycle, and this catalytic cycle is almost similar to that you have seen in the different reactions, different coupling reactions, as I have mentioned you. Actually, we are taking any palladium complex that may be in palladium 0 oxidation state, or it may be in palladium plus 2 oxidation state. These complexes we are taking out. Okay, these are called pre-catalyst. We cannot use it as it is. Why we cannot use them as it is? Because suppose we are taking PD PPS3 whole 4. This is a ligand, PPS3 ligand. Okay, and this is the complex of 4 coordination number. Now in this complex, if you look at, it is actually 18 electron species. So it is inactive. It cannot take part in the reaction. It cannot undergo the oxidative addition reaction. So we cannot take it as it is. So firstly, it will remove 2 ligands, means 2 ppS3 ligands, it will leave out. So now you are getting palladium with 2 ligands. I am writing down them L because these are ligands. These may be ppS3, these may be TBA, anything. So here now we have taken PdL2. Okay, here palladium is in 0 oxidation state. Okay, and now coordination number you can see is equal to 2, and it is having 14 electron count. Okay, so Now it will undergo the oxidative addition reaction with the halide. Okay, now halides meet to it. It is a oxidative addition reaction. We have discussed this oxidative addition reaction in a very clear manner in the organometallic reactions. Okay, we have studied the organometallic reaction mechanism in the playlist of organometallics. You can see them on the YouTube. And if you want the detailed course, then you can visit our app. Full courses of inorganic chemistry and physical chemistry now are available on our app with the PDFs, lectures, mock test, assignments, all the things. Okay, and in very low price. Okay, so you can check out that. Links are given in the description box. Okay, so firstly, see here. When you see the oxidative addition means firstly there is happening the oxidation of metal. Secondly, there is happening addition means now its coordination number is increasing by 2. So 2 ligands and 2 more ligands R dash and X are attached to it. It means now its coordination number has been become 4 and its oxidation state has been increased by 2 and its electron count is now increased by 16. Okay, when you understand the organometallic reactions, you always see this electron count. Okay, if you are studying for organic chemistry, then you does not need it. But if you are studying, then study in a better way so that you can understand the whole concept. Okay. So now what is happening? Now we take our zinc reagent means R2ZnX. This reagent we are taking here. Okay, so what will happen actually? See here what is happening. Firstly, a additive compound is formed means in this manner this X is linked to it and similarly this R2 is linked to it and it in this manner. Okay, just like this. And this is R1, this is Ln ligand, this is X, another X. Okay, so actually transmetallation is happening means the R group is being transferred between two metals. This is called transmetallation. And if you want a detailed way of it, you can see in the organometallic lectures. Okay, so in transmetallation, just there is the replacement of the R group between the two metal atoms. Okay, so just you have to see the replacement. Okay, means Zn(X2) will come out and this R group will go with the palladium. Okay, so now you have palladium with two ligands R1 and R2. Okay, but they are in trans manner. This is trans structure, and in trans structure, reductive elimination is not possible because the two groups that wants to leave out are trans to each other, so they cannot form a bond. So there will be cis trans isomerism. Okay, so the next step that you are seeing here is the cis trans isomerism. As a result of this, now you are getting a cis type of compound. R1 is here, R2 is here, this is L and this is L in this manner. Now it can undergo the reductive elimination. Okay, so it will undergo reductive elimination. So as a result of the reductive elimination, what will happen? This R1 and R2 will make a bond and they will leave out. And you are getting your complex as it is. So this is called reductive elimination. Okay, so this is the whole catalytic cycle. Now just look at this catalytic cycle. See here what is happening. You have taken this palladium complex. Okay, and it is undergoing the oxidative addition reaction, the first step with the halide. So it is forming a 4 coordinated complex. This is a 4 coordinated complex that is formed. Okay, and now this complex undergoes transmetallation with the organo-zinc compound. Okay, so there is the exchange of the metals between them. So you are getting this trans structure. Okay, this will undergo the cis trans isomerism, and as a result, you are getting a cis product. Now this cis product will undergo reductive elimination, and you get your product. This is your product that you want. Okay, So this is whole about the catalytic cycle or the mechanism. I think now you got clear. Now we comes to the examples. See here the examples. If you have given any unactivated halide. Unactivated halide means when zinc is not attached to it. Okay, you have not given the zinc attached compound. Organo zinc compound you have not given. Okay, this happens generally in the question papers. So what you have given? You have given in this manner a bromide. Okay, and then you have given zinc. You are treating it with zinc and iodine. Okay, so as a result, you are getting organo zinc compound in this manner. Means you are preparing the zinc organo zinc compound in situ. Okay, and then it is treated with ARX. In the presence of the catalyst, either you can take nickel catalyst or you can take palladium catalyst. So as a result, this bond will break down and this bond will break down. Okay, and you are getting RAR. In this manner, you are getting your compound. Now see the second reaction. Suppose you have given this compound, okay, and you have given a series of reactions. Actually, in question papers, you have given the series of reactions. You have not given the single reaction. You have given different reactions simultaneously. So you will have to go one by one with each reaction. Okay, just concentrate the mind and see what is happening. Okay, then you can do the questions. See here, this thing you have given. Okay, so first reason that you have given is the butyl lithium. So firstly, we are treating it with butyl lithium, and I think you know what is the role of butyl lithium. Actually, it is a very strong base. It will abstract the acidic hydrogen. Okay, so from where it can take the hydrogen from the less bulky side, it will take. Okay, and it will attack at this side. Okay, so this thing you should know that which is less acidic hydrogen, which is more acidic hydrogen, which is less bulky side, which is more bulky side. Okay, and if you don't know about this, then I will make the videos of GOC so that you can understand this whole concept. Okay, so just comment me and tell me whether you want to know or not. So you are getting in this manner an ion. Okay, in this manner you are getting. Now it is treated with in second step ZnCl2. Okay, here actually, if you see, this will be just in this manner. Here is minus charge and here will be Li in plus manner. Okay, so LiCl will leave out. Okay, and you are getting here this whole structure that you have given, whether it is complex or simple, nothing to worry. Okay, you have to write down it as it is, whatever is the structure. So you are writing in this manner. Now here you are writing ZnCl. Okay, this is your organo zinc compound because to carbon zinc is being attached. Now the third step is the reaction with the PD PPS3 whole 4. This is your catalyst that you know, and you are treating it with this compound. Okay, this compound you are taking here. This is a bromide. You are seeing this is an aryl bromide. So actually, if you concentrate on mind, you find out that this is the Negishi reaction that is happening. Okay, this is Negishi reaction. So now you have to do what thing? You have to break down the bonds. Okay, here from here you will break down. See here, from here you have to break down the bond, and in this compound from here you have to break down the bond. Okay, so now you have to make. So see here, this is the zinc. So from here you have to break down the bond, and from here you have to break down the bond. So what you are getting? Now you have to make a structure in which you have to join the two compounds. So firstly make the zinc compound. In this manner, you have to make the zinc compound. Actually, I have taken all the questions from the reference books. So the structures are complicated, but actually in the question papers, you have given the questions of the reference books. So you should do the questions from these books. Okay, so see here, I have made a bond between the two groups. This is the bond. I am making it by white color so that you can understand this is the bond that we have made. Okay, so now double bond and double bond N and here O. This is your structure that you want. Okay. In this way you have to prepare the compound. Alright. Now we come to the next structure. See here the third one. This is the compound you have given and you have given palladium in zero oxidation state with THF as solvent. Okay. So see here you have given two different compounds. So you have to break down the bond from here and one bond you will break down from here. Okay. And you will make the structure. Stereochemistry will remain as it is. There is no effect on the stereochemistry. The reaction happens with the retention of the stereochemistry. Okay. So just you have to make the bonds and this will be your answer. In this way you have to do. Okay. Now see the next question. See here you have given this one structure. Okay. Now you have given ZnCl2 and tertiary butyl lithium. You have not given the organo-zinc compound. Okay. But you have given the conditions for that. Firstly, tertiary butyl lithium is reacting with this iodide. Okay. It is forming LiCl and here then ZnCl2 will react. Okay. So you will get here in this manner. See here in this manner as I have made in the earlier example. Same manner you have to do. In the same manner you have to do. You will have to make here ZnCl in this manner. Okay. Now it is reacting with this compound. Okay. The second one compound is being reacted with it in the presence of PdPPS3 whole 4. So what you are getting? You are making, see here. Firstly make down this structure. That is halide. We are making the structure that is given on second number. Okay. And then see here. This was iodine. So we have to break down this bond. Means this bond you have to remove in this manner. Okay. Now you have to make a new bond. Okay. So I am making this by different color so that you can understand. This is the new bond and then you have to make this zinc compound. The bond with the zinc will break down. Okay. So here you are getting Me and Me and the group. In this manner, this will remain as it is. So this is the structure that you are getting. Okay. Now see the next example. See here you have given this compound. This is treated with lithium and tertiary butyl. In this manner you have given the compound. This whole twice, this group. Okay. So what will happen? Actually when you are treating it with lithium, then what happens? This ring will open. Okay. This ring will open down. You are getting lithium here and OLi here. Okay. Now you are treating it with ZnBr2 and PHBr. Okay. So this is PdPPS3 whole twice OAC whole twice by which you are treating it. So now what happens? This ZnBr2 will react with Li and it will form, see here. Firstly, it will form in this manner. This will OLi and here you are getting ZnBr. Then it is treated with PHBr. Okay, then it is reacting with PHBr. So it is forming, see here, I am making here. Here this will get hydrolyzed, so you are getting OH here and here you are getting a new bond and then you have to make the phenyl group. Okay, so this will be the compound that you are getting. Okay, now see the next question. See here, now you have given an organo-zinc compound. So you have to break down the block from here and you have given iodide. So you have to break down the bond from here. Okay, and you have to make a compound by coupling. So this is the compound and now you are making a bond from here. So this will be the bond and you are getting this compound. Okay. So in this way different types of reactions are happening. Okay. So these are all about the Negishi coupling reaction. I hope you got understand what is happening actually in this reaction. I have given you several examples and if you want the detailed course then you can visit our app. Okay. If you want many more topics on the YouTube, then you can comment me. I will provide you that videos. Okay. So meet you in the next lecture. Thank you.